exercise 610, perimeters of composite shapes. The perimeter of a shape is the distance around the shape. To find perimeter, add the lengths of the sides together. The perimeter of a circle is called the circumference. And remember, you can use two formulas for circumference. I prefer just to use one, but you can use what you want. If you know the diameter, circumference equals pi times d, where d is diameter. Do you remember that? I don't like using that one. You can if you want. Or you can use, what's the other one? If r is the radius, circumference equals 2 pi r. Okay? Remember, diameter is the distance, if you're going through the center from one side of the circle to the other, going through the center, that's the diameter. The radius is half the diameter. Distance from the middle, center of the circle to the outside. Doesn't matter how many radii I draw, they would all be the same length. This first example. So find the perimeter of the following composite shape. So we know that's 75. We know this is 25. The base we don't know. I'm going to call it x. And this whole length here is 85. The problem is I don't know what x is. But I know that x is the same size as this dotted line here. And I know I've got, these are right angles in the diagram. I know I've got also a right angle triangle here. Now this hypotenuse here is 75. What is this length that I'm pointing to here? The whole thing's 85. That's 25. This bit's 60. Why? Because 85 minus 25 is 60. Now, you can use Pythagoras' theorem two ways. You can use it to find the lengths of the longer side or find the lengths of the shorter side. So if I write x there, this is also x because it's the same. I'm going to put x. When you want to use Pythagoras to find the shorter side, right angle triangle, there are two things you can do with right angle triangles. One is Pythagoras and the other one is to use trigonometry, sine, cos or tan. Now, if I wanted to use trigonometry, it'd be asking me to find an angle or something here. But if you've got two side lengths and you just want to find the third side length, we use Pythagoras' theorem. Okay? Do we remember what Pythagoras' theorem is? It's the squares. It's got to do with the plus, yeah, or yeah, you could do it two ways. Girls, the sum of the two smaller sides squared equals the larger side squared. Okay? So I can set it up going x squared plus 60 squared equals 75 squared, or you can just do it in one step. You look at it and you say, right, the hypotenuse is always the longest side. So in a right angle triangle, the hypotenuse is opposite the right angle, and the hypotenuse is always the longest side. So how many of you do 75 squared minus 60 squared? Are there people that go in and do that straight away? All right, you can do it like that, and I do it like that. But if ways we can do this, if you can just do two smaller sides, does it make sense that the two shorter ones would add up to the bigger one? But not, you don't just add them. You go x squared plus 60 squared equals 75 squared. How do we know which one's the longest side? It's always opposite the right angle. So x squared plus 60 squared equals 75 squared, but we're trying to work out x. So x squared, the other way you can do it is, if you're finding the shorter side, it's obviously the longer side squared, 75 squared, minus the other shorter one squared. So you can go straight to that second line first if you want, or you can write it as x squared plus 60 squared equals 75 squared, and then just take this plus 60 squared over and make it minus 60 squared. So x squared equals, now what's 75 squared minus 60 squared? $2,025. Therefore, x is, so girls, we would never have a triangle that's 60, 75, and 2,025. For a start, x has to be smaller than 75. 75 is the longest side. Remember, that's x squared, so x is the square root of 2,025, which is 45? So therefore this missing side length is 45. So therefore the perimeter is just adding up all those lengths. We've got 85, because 85 is that whole length, plus 75, plus 25, plus 45. Okay? And, or 300 and 230 millimeters. Okay, so just be careful with Pythagoras' theorem. If it's a shorter side, you can just set it up the same way every single time. X squared plus 60 squared is 75 squared. So x squared would be 75 squared minus 60 squared. Work it out. Or if you know you're working out a shorter side, it's always the other longer side squared minus the other shorter side squared. Or if you're working out the longer side, you would add the two shorter sides squared. Question 2D is to find the perimeter of this shape. Now, you look at what you've got. You've got straight length 6 plus 4 plus 6. I need to find the curved bit. Okay? When you do perimeters of composite shapes like this, you've got the straight bit, the straight bit, the straight bit. So let's just go straight lengths. What do they add up to? They're 6 plus 4 plus 6. They're 16, I think it's centimeters, the units. Now we need the curved bit. The curved bit. How much of a circle is that? Isn't that half a circle? What's the formula for a full circle? This is a semicircle. Yes, you could use pi times d, or you could use 2 pi r, whatever you like. Now, what I'm going to do, we've got that there. What do you know about that circle? You know that the diameter is 4. So for that circle, I know the diameter is 4. But that's just a half circle I want. Are we okay, girls, or not? So the perimeter or the circumference of a full circle is pi times d for a full circle. Can I now divide it by 2 for half a circle? Divided by 2. Do you want me to do it in 2 steps or not? All right, so the circumference, see here I've got a half circle. So it's pi times d divided by 2. So it's pi times 4. You need to know whether you've got the diameter or whether you've got the circumference. See, what I've got there is the diameter. Sorry, the diameter or circumference. The diameter or the radius. I've got the diameter. I just need that bit there. So a whole circle would be pi times 4, but I've only got half a circle, so I divide it by 2. So pi times 4 divided by 2 should be 6 point something. 6.28, I'll just go centimeters. So therefore, the overall perimeter is, it's 16 centimeters plus 6.28, 22.28 centimeters. I'm not sure how many decimal places they want this to. Centimeters to 1 dp, 1 decimal place. Please don't go adding this 4 here in the middle twice. That's just a dotted line. The shape goes around like that. So perimeter is distance around the shape. It's not internal dotted bits. Okay? All right, this is a quadrant. So another example, find the perimeter of this quadrant. Again, it's made up of straight line bits and a curved bit. So if that's 5 centimeters there, even though I haven't indicated what this is part of a circle if I draw a dotted line, dotted circle. So if that's 5, what's this length here? What's this? 5. So the straight line bits or the straight pieces, straight edges, are 5 plus 5, which is 10 centimeters. Now my curved bit. I'd want how much of a circle there? Curved bit equals how much of a circle? Isn't that 1/4 of a circle? So, now, okay, you can use D, but I've got the radius here. So what do I know about this circle? That the radius is 5. Okay, so with this circle, I know that the radius, now if you're not sure, I just do dotted line all the way around. I can see that's the radius. So, and So it's quarter of a circle, so it'll be a quarter of, or you divide by 4, same thing. Okay? Circumference of a circle is 2 pi r, so it's 2 times pi times the radius is 5. You can do, I don't mind if you do 2 times pi times 5 divided by 4. If you prefer to divide by 4, or you can times it by a quarter. It's the same thing. Just don't go timesing it by 4. All right? So, or you can write it as 2 times pi times 5 divided by 4, if you want. If that makes you feel better, do that. Yes, if you want, actually, yes. Some people go like this. Full circle is 2 times pi times 5, but I wouldn't work that out. I would just leave it, because then you're going to get rounding errors otherwise. So, you know, here you can write 2 times 5 is 10 times pi. Are you okay with that? And then you go the quarter of the circle is 10 times pi divided by 4. You okay with that? So I'm happy for you. If you want, do it all in one step. But if you don't like doing it in a step, go full circle is 2 times pi times 5, which is 10 times pi. Quarter of the circle is that divided by 4. Anyone got an answer? 7.8539, etc. So here it's also the same, 7.8539 ... And so therefore the perimeter is your straight edges, which are 10 plus the 7.8539 ... And it's 17.8539 ... 1 decimal place, 17.9 centimeters. Now, if you have to do the full circle first, go ahead. Full circle, quarter of a circle. Got it? I'm happy for you to do that. But see, I wouldn't be working out this now and writing 31.4, whatever it is. All right? Because then you've got to write, so 2 times pi times 5 is, it's like algebra. 2 times 5 is 10, it's 10 times 5. Or, sorry, and I should have written the formula up here, a quarter times 2 pi r. Are we okay? I should have written the formula there. It's a quarter of 2 times pi times r. All right, good idea to write the formula. So circumference is 2 pi r. Good idea to write the formula, girls. All right. Okay, girls, notice there are no straight line bits in this shape. It's a curved bit, a curve, a curve, a curve. And all those curves are identical. So the problem here is to work out how much of the circle you've got. Now, it looks like they've got a right angle here. Okay, so we've got, like that is one bit, and it's, oh, geez. And it's got this cut out. I'm just looking at one section, and to me, it looks like a quarter of the circle's cut out. So that means, yes, Pac-Man. So it looks like we've got, if a quarter's cut out, we've got 3/4 of the circle left. So what I'm going to do, let's go full circle. Let's just see what we've got, by the way. Full circle is 2 pi r. That's how you find the full circle circumference. So circumference of full circle is 2 pi r. I should just write C. You've got 3/4 of your circle, don't you? So it's 3/4 of 2 pi r. Girls, do you know how to, and how many of those do you have? That's 3/4 of one circle. How many of these, how many 3/4 do you have? All right, you can work that out if you want. Girls, all right, let's go. 3/4 of one circle. So 3/4 times 2 times pi times, what's the radius? 5. So the radius is 5. You can work it out if you want, girls. Look, that only does one piece. Do you want to do all of them before we start putting things into our calculator? So the four shapes. Can I write 4 shapes? So the 4 shapes will be Girls, you can simplify this if you want. What's 3 times 2? Times 5. 30. So that's 30 pi over what? What's on the bottom? You okay with that? All right, so the 4 shapes will be 4 times all of this. Does that make sense? Girls, 3/4 of 2 times pi times 5. Keep the pi there. You just can multiply all the numbers on the top. 3 times 2 is 6. 6 times 5 is 30. Remember, these would be all over 1. And on the denominator, we've got 4. Or 4 times 1. So it's 30 pi over 4. So for the 4 shapes, the entire thing, it's 4 times 30 pi on 4. What do you think happens with those 4s? They cancel. The entire thing is just 30 pi, the perimeter. So if you wanted, you could have gone, yep, full circle, 3/4 of a circle, the 4 shapes. You could have even done it here, 4 times 3/4 times if you want. But look, you know what I would do? This would be worth a couple of marks, 3 marks. Every time you get somewhere, you're going to get a mark. So it's probably not bad to do it in steps. Because then they'll know, yes, we can give them a mark here, we can give them a mark there, all right? So the perimeter will be 30 times pi, which is 90 what? Exactly? No. Rounded? All right, can I have just exactly what it is? 94.2 what? We want it to 1 decimal place, so I'm not sure. Yeah. No, but I want it to 1 decimal place. So I need to know, no, but it might not be 3 in case your 2.5 was rounded. So 94.2 what? I need exactly what it is. 30 times pi. 94.2, thank you, 247, etc. Now, rounding that to 1 decimal place is 94.2. Got it? That's why we've got to be careful. So write it out, and it's 94.2 centimetres. Okay.